I put together a talk that's got a lot of different elements to it, but I wanted to give first an overview of sort of the marine mammals we have off the coast here. And then the next two lectures, webinars will be on how do we learn as much as we've learned about these animals? And then an in-depth look at the animal that I've spent basically my whole career working on in one way or another, is the northern elephant seal. So let's start out by recognizing these are marine mammals. And I think it's always fun to go back and say, well, what is a mammal? And so viviparous means they give birth to live young. They have hair. They lactate, which is an unusual thing about vertebrates. They have a 4-chambered heart. Bird has that as well. They're warm-blooded. They have endothermy. Diphyodont means 2 sets of teeth. That's a unique mammalian characteristic. We remember milk teeth, when little kids, your teeth fall out. The other thing that's characteristic is we have 3 inner ear bones, unique respiratory system, and then this is the one that I think is kind of fun. All mammals have 7 cervical vertebrae. So whether you're a dolphin or a giraffe, you have 7 cervical vertebrae. So that you have 7 bones in your neck. And in a giraffe, they have 7 and each one is longer. And in a marine mammal, and in a cetacean, there's the 7 cervical vertebrae. This is a blue whale out at Long Marine Lab. You can count that there are 7 actual vertebrae in the neck. So these are just kind of characteristics to say that marine mammals are in fact a mammal. And there's about 126 different species. That represents about 3% of the diversity of all mammals. And marine mammals have gone into the ocean at least 5 times. We have cetaceans, that is going from a terrestrial ancestor to a marine mammal. All the cetaceans, amazingly enough, their most common terrestrial ancestor is a hippopotamus. Seals and sea lions, the closest ancestor is the ancestor of bears and dogs. Dugongs and manatees, the sirenians, their closest ancestor is an elephant. And then we have polar bears, which are an independent origin from terrestrial bears. And then the sea otter, which is a terrestrial ancestor, is a mustelid, and river otters and minks and wolverines and the like. So everybody probably knows that the blue whale is the largest organism to have ever, well, I should say our largest animal to have ever lived on the face of the planet. They're about 100 feet long, and they get up, the record is about 150 tons, big animals. One of the things that's amazing is we could spend a lot of time just talking about the various adaptations, and the skull morphology of these guys is something that's quite amazing. And this is just a collection of different skulls. Here we have, down here is a porpoise, bottlenose dolphin, a killer whale. This is a beaked whale. We'll talk a little bit about them. And this is a river dolphin. We don't have those anywhere here. But one of the things we see that the odontocetes, odonta meaning the toothed whales, is a skull asymmetry. And this is a dolphin skull. And you can see the blowholes, the nasal passage, it's slightly asymmetrical. But if we look at a koja, which is a pygmy sperm whale, this is one nasal passage and this is the other. Extreme asymmetry in the toothed whales. We could talk about why that is, but basically it has to do with the fact that echolocation, you need to be able to distinguish left and right, just like our ears are slightly different, so we can tell the difference in where the sound is coming from. But in odontocetes and toothed whales, it's very, very extreme. Okay, so now I'm going to talk about when we talk about animals, marine mammals, I like to really fundamentally talk about their habitat. And so why are they off the coast of California? In fact, we have the most diverse marine mammal fauna anywhere on the planet, which is kind of amazing when you think about it, because the polar regions have a high diversity of seals and ice seals, but we have the most diverse assemblage of cetaceans, of pinnipeds, seals and sea lions, and then we throw in the sea otter. All of these things are driven by oceanography. And so the evolution of these animals was led by the localized upwelling, localized high productivity, but it starts off our coast here with wind. So this was a project a colleague here, Don Kroll, started called Wind to Whales. And so the wind blows, which drives upwelling processes. We know in the spring when the coast here, we get that tremendous wind. That brings cold water to the surface, which brings nutrients. which then diatoms and phytoplankton grows. The krill, which is this little shrimp-like animal, feeds on the phytoplankton. Salmon and, I mean, krill are a major part of the food web. And so whether it's seabirds, fish, squid, or blue whales, this relationship in terms of what drives this highly productive offshore system that we have off the coast of California is dependent upon this wind-blown upwelling. Now, we're going to talk a little bit about why that's important for blue whales. And as I said, blue whales are about 100 feet, 30 meters. They were hunted extensively until the mid-1960s. They were the first whale to be protected under the International Whaling Commission. And they're an animal that's very common off the coast here in the summer and into the fall. Now, these are some tracking data that colleague Bruce Made at Oregon State has collected. And you can see we're right up here. And so each one of these different colors is a different individual blue whale that was tracked with satellite tracking. And what you can see here is these animals are moving up and down the coast. Down here is this area called the Costa Rica Dome. It's created by wind that's driven across, going from the Gulf of Mexico, and it drives a localized upwelling here. We know this is where we see calves, and we see calves in the Sea of Cortez. And so we've never seen breeding, but we suspect, because we see calves and we don't see them anywhere else, that they're calving in here in the Sea of Cortez and down here in the Costa Rica Dome. So when they're not here in California, not off our coast, they're somewhere along this trajectory down off Baja to the Costa Rica Dome. So why did they come up here? They come up here because this is one of the most productive regions in the world. And this is, again, upwelling. So as the winds are blowing in this direction, northwesterly, coming from the northwest, it creates a situation where water flows offshore. And as the water flows offshore, colder, deep water comes up. So that's what we call upwelling. And this is a sea surface temperature map that shows this cold water along the coastline. It's warmer offshore, it's colder inshore. So one of the reasons it's so cold in the springtime is because of this upwelling. It's not just because the water is cold, it's because it's colder, deep water that's come up. As I mentioned earlier, that upwelling brings nutrients with it. And this is a satellite image that shows the highly productive, this is sort of the chlorophyll measurement of the plant content of the ocean, the phytoplankton. You can see that all of this cold water is associated with high degrees of productivity. So that's the base of the food web. This wind to whales concept comes forward here. We can see as the northwesterly winds blow, we get this upwelling. So this is water depth on this axis. This is time of year. So this is January to December. So this going across this is season. From left to right is seasonality. The winds are blowing in the springtime. This is water depth, and then the colors of temperature. You can see this upwelling, this colder water here coming to the surface in March, April, mostly April, May to June. We can see this colder water coming up. And then if you go out and measure the uptake of carbon that's phytoplankton growing, you can see that there's an increased growth of phytoplankton, again, seasonally. And then if we look at the chlorophyll content, so this means the organisms, the phytoplankton's now more abundant. You see that seasonally it's abundant. And then if we use a fish finder, a very sophisticated fish finder, we can see that krill start to come up. So this is the food web. You get the wind that blows, that brings the cold, nutrient-rich water. Phytoplankton grow, the phytoplankton become very dense. And now the krill begin to feed on the phytoplankton, and then the whales come. And the whales then feed on the krill. And so you can see the whales coming in July and leaving we still have some around into October, but gone by the end of the year. And this is the rest of this time is where I showed you that they were south of us, off Baja or off Costa Rica. So when they're in the Monterey Bay, this shows where the sightings of blue whales are along the coastline. You can see here's the Monterey Canyon. This is the continental shelf here. The blue whales tend to aggregate along this shelf break. This is the edge of the continental shelf. And we can see whale aggregations here. You can barely see the background that shows the Monterey Canyon here. But here is a picture of krill, again, using a sophisticated echo sounder. Here's a whale track above. And so the whales are associating with where the krill are. And the krill sort of associate with this continental shelf break, because in the nighttime they come to the surface, and the daytime they hide here to avoid fish predators. Now, the irony is by avoiding fish predators, because they go to the surface at night, where the fish can't see them to feed on them, and they go down to deep and create these very large aggregations in the daytime, they become perfect whale food. They become perfect whale food because blue whales have this amazing ability, as do all the family Balaenopteridae are all the rorquals. And they're kind of like a pelican. Their lower jaw is sort of like a pelican's jaw, where they basically can engulf an entire school of krill. And that's why they come up here, because we have lots of productivity. The wind blows, drives the whole ecosystem, and the whales come and feed very low on the food web, the first consumer level, which is krill. So that's just one of that's the largest critter. We also have fin whales, and fin whales are a little further offshore. They're much harder to see. They're the second largest of the whales. They look very much like a blue whale. However, I used to ask people who knew a lot more than I did when I was earlier in my career, what will it be like when I see my first blue whale? And fin whales are easy to see because they blow and you see the fin, and that's why they call them a fin whale. Their fin is very evident. When you see a blue whale at sea, you know it's a blue whale. There's nothing like it. When it blows, you see the blow and you see the back roll and roll and roll, and finally you see this little tiny dorsal fin. So fin whales are the second largest. Again, blue whales are the largest. These guys are interesting is that they have an asymmetry where the lower jaw, the right side is white, the left side is gray. Other thing I didn't say about blue whales, why do they call them blue whales? They're kind of a blue-gray color, so they really are blue in terms of their color. The animal that's probably most predictable and is most not animal, the cetacean, the large whale that's most reliable in Monterey Bay and along our entire coast, going from Southern California up off the Farallones. So it's an animal that you are most likely to see. It's just that they're reliably present in Monterey Bay, and that's why we have such a lot of, quite a few whale watching cruises. But again, from San Francisco, you can get off the Farallones, we get lots of humpback whales up there as well. Now, humpback whales are very unusual for the rorquals. They have these knobs on their head, which are actually where they would remnants of hair follicles, and they have extremely long pectoral flippers. These are some pictures taken in Monterey Bay. Notice also it has a very unique dorsal fin. Only humpback whales have this sort of almost dolphin-like dorsal fin, and it's sort of elevated over the back. Here you can see those knobs, which are remnants of where there would be hair follicles. The other thing about the mysticetes cetaceans is they have two blowholes. When we see some pictures of the toothed whales, the odontocetes, they have a single blowhole, and so that's another defining characteristic. You will often see humpback whales feeding in large aggregations with these are seagulls and some cormorants. It's pretty amazing when you see these guys feeding. You can see all the little fish that this humpback whale is feeding on. Here's California sea lion, just a tremendous abundance of animals. When they're in Monterey Bay, humpback whales tend to feed on fish, whereas blue whales tend to feed on krill, well, almost exclusively feed on krill. You can see that large, the throat opening up. And the other thing that humpback whales are well known for is their gregarious feeding, is they will work together and throw bubble nets and other various things to entrap that school of fish, because the fish are pretty fast. And so they got to create a situation where the fish remains in a school so they can scoop up that whole school. So I mentioned that humpback whales feed predominantly on fish and blue whales feed on krill. And this is some work that a number of colleagues have been doing really looking at the dynamics of feeding behavior, and I don't have time to go into it in great detail. But what is interesting is there's a scaling relationship such that the smaller whales, because they're small, they can't engulf as large a school. A blue whale, being the largest, has the greatest capacity to swallow a big chunk of the ocean. And so there's a relationship between the density of these krill swarms, the density of the fish schools, that really sort of creates these different situations of the size of the predator and the way they go after their prey. And this just shows you the prey of a humpback whale, I mean of a blue whale, prey of a humpback. And so humpback whales are feeding on larger prey, but in smaller schools. Blue whales are feeding on small prey, but in extremely large, dense swarms. So now I'm going to talk about the other animal that is extremely reliable, and by the way, is the state marine mammal. The California gray whale is the state marine mammal. It lacks a dorsal fin. It has this sort of series of knuckles instead of a true dorsal fin. They're about 35 feet long, 11 to 12 meters. And they have one of the longest migrations of any mammal. Now, this is actually a picture taken in the breeding lagoons down in Baja California. And just to give you an idea, the gray whales feed up here in the Bering Sea, and they migrate down every year down to the breeding lagoons down in Baja California. This is where they calve, this is where they breed, and then they swim back up the coast. And so the breeding happens in the wintertime, you know, January, February is when the breeding. So November, December, we see the migration going down. And then in the springtime, we see the animals going back. During most of this migration down, they're fasting, although there are individuals that are resident gray whales that are sort of staying up in the Pacific Northwest. Typically, they feed on benthic prey, on amphipods, but in this region, they'll also feed on mysid shrimp. Yeah, so here's the, and there are, if you guys are interested, there are a number of commercial operators that you can go to the breeding grounds off Baja California. So just quickly recap, they have a 6.5 months on the foraging grounds. They migrate south about 1.6 months. They're in the breeding lagoons for about 4 months, and then they go backward up north. And this is during this period of time, the females are pregnant. This period of time, they're lactating, and it takes at least a 2-year cycle. So they give birth, stay with the calf, go and then replenish themselves, feeding, and then they go back south, and then they reproduce, and then they start the whole process again. So this makes, and they also, the thing for us is they migrate right along the coastline, and we think that a lot of that is to avoid killer whale predation, although killer whales certainly do attack them, but they're safer in moving along close to the shore on the continental shelf than they would be way offshore. Okay, just some fun pictures. I was actually fortunate enough to go down last March, my last trip before COVID hit. Well, COVID hit, and before we couldn't travel. I was a naturalist out of the Cabrillo Museum down in LA. We went down on one of these tours, and it's where you have the friendly whales that you can actually go and pet a gray whale, which, you know, it's kind of fun, but it leaves, I mean, the whales actually will approach the vessels. So it is something that they do on their own. It's not like we're forcing them to be petted. So the last of the mysticete cetaceans, the baleen whales, is the smallest one. It's the Minke whale. It's this little guy. We have them off the coast here, but to be honest with you, I don't know that I've ever seen a Minke whale off the California coast. I've seen them in Alaska. I've seen a lot of them in Antarctica. They are out there. They're much more secretive. They will do some aerial maneuvers and stuff, but they're one that you're probably, of the big whales, they're the one you're least likely to see. But they're out there. They're just small and secretive. So now if we move to the toothed whales, the Odontocetes cetaceans, the largest one is the sperm whale. We do have them off the coast here, but you're not likely to see them unless you go off into deep water. So they don't come onto the continental shelf. These are a true deep water whale. And so if you go out to the continental shelf break and just on the edge of that, that's when you'll start to pick up things like this. And occasionally we'll get them into Monterey Bay coming up the Monterey Canyon. Pretty magnificent animal when you see them. Another one which also lives in that same offshore deep water realm are the beaked whales. And this is one of the most diverse groups. They're historically the group that we know the least about. This is a Cuvier's beaked whale, which is a rather large whale. These scratches, these white marks are scars from interactions probably between males fighting for dominance of females. Because these guys live in deep water off the continental shelf, they're traditionally an animal that we really don't know much about. But ever since they were implicated as being very sensitive to seismic surveys, to naval operations, the US Navy and other agencies have put a lot of money into studying them. And miraculously, even though it's one of the hardest whales to study, in the last decade, we've learned more about these guys than almost any other group. And I'll talk a little bit about how we do these studies next time. I could go on and on about beaked whales. They're a very amazing, interesting group. But again, they're one that we've only recently begun to understand. So now I'm going to move to the family Delphinidae, and these are the dolphins. And they are characterized by what we call this falcate dorsal fin. And this is a classic, the characteristic of members of the Delphinidae. They also have a beak. All members of well, almost all, because pilot whales they have sort of a beak, but not really. The bottlenose dolphin is one of the most common throughout the world. This was a picture that I don't know the sex of these animals, but males tend to pair up. The females travel in bands of groups of related females, and males tend to pair up and pair up sort of as a bromance, if you will. Single dolphins don't do too well in the wild, and so this is probably both an anti-predator relationship as well as they share responsibilities of when a female comes into estrus. It's harder to mate with a female if you're a single animal, and these guys sort of help corral the female. That's work that Randy Wells, he's affiliated with UCSC. He's been studying bottlenose dolphins in Florida for the last 40 years. Another animal, which if you go out whale watching, especially in Monterey, and you go out to the continental shelf break or in the Monterey Canyon to the sort of the south edge, you'll see these guys, which are pretty cool. These are Rhesus dolphins. You know, they're in the realm of a large dolphin, small whale. And you might ask, well, what's the difference between a dolphin and a whale? Well, size. There's no taxonomic difference. These guys are also a very deep diver. And they're one that if you go to the right place, you can almost reliably see them. These are, again, Rhesus dolphins. And these guys don't, again, remember, there's always some exceptions to the rule. There's more of a lip than a beak. And so when I say that all members of the dolphin family have a beak, there's a few that kind of throw that out a little bit. But again, notice this, what I call that falcate dorsal fin. These guys tend to travel in large schools. And so that's the other thing that probably makes them easier to see. One of my favorite little small cetaceans is Lissodelphis, the northern right whale. And they call it the northern right whale dolphin because it lacks a dorsal fin. And right whales don't have dorsal fins. So somebody decided we should call these guys the northern right whale dolphin. They're very well, they're not colorful. They're strikingly marked where their belly has this very interesting white pattern and their top is black. They're really super fast, aerobatic. They swim and move around really rapidly. They're often seen with Rhesus dolphins. So you get these mixed species flocks, schools, not flocks, not birds. We don't know very much about these animals because again, they're sort of offshore or off the continental shelf. But they're really cool to see. I just always enjoy seeing them. They're small. They're a smallish dolphin. Whenever I see or think about these guys, I wonder why they don't have a dorsal fin. Why does all the other members of the dolphin family have dorsal fins? Why don't these guys? And I have no good explanation. Nobody's come up with a rational explanation for why that might be. The other guy that we see periodically here is the Pacific white-sided dolphin. Again, a very striking dolphin with a really beautiful, color, not a color pattern, but well, I guess color, it's grays, shades of gray. They have this very classic blaze on the dorsal fin. Again, notice the shape of the dorsal fin, that falcate dorsal fin. There is a bit of a beak here. You can't really see it, but there is a little tiny, kind of almost, it's a little tiny of an indentation. These guys, I'll show you a figure a little bit later, that these guys sort of move up and down the coast. And so Monterey Bay is about the area where we tend to see them. When we have colder water, these guys come in. When we have warmer water, let me go the wrong way. Warmer water, these guys come in, the common dolphin. And so you can see they both have striking patterns, but the common dolphin is very different in that it's got a true beak, much more like a bottlenose dolphin, and the color pattern is very different. And it's got this, again, that classic falcate dorsal fin. So these guys are here when the water's cold. These guys are here when the water's warm. And so depending upon the oceanography and how the climate's moving around, we'll get common dolphins or we'll get Pacific white-sided dolphins. Both tend to swim in large schools of hundreds and sometimes thousands of individuals. This is a photo. Again, you can see the defining characteristic is no color on the dorsal fin and this very solid white blaze. And then it's a common dolphin. This is a picture taken in the Sea of Cortez, just showing you the size of the schools that you can sometimes see. Okay. Killer whales. Killer whales are a dolphin. People think of them as a whale, but they're actually the largest member of the dolphin family. And these guys have a matrilineal family groups. They swim in pods, and there's very strong matrilines. And again, you can see this very striking markings, this very striking patterns. Again, notice that it's shaped a little bit differently, but this little guy, you can definitely see that falcate dorsal fin. Certainly putting them in the dolphin family. There are three morphs of killer whales. There's forms that one are the residents, which feed up in the Pacific Northwest, feeding on salmon predominantly. There's an offshore group which feeds on stuff. We're not entirely sure, but we think sharks and skates and rays. And then there's the transients, and the transients eat other marine mammals. The ones we see here in Monterey Bay tend to be the transients, the guys that are they'll periodically come into the area and they'll roam up and down the coast going thousands of miles. Some of the individuals that we have seen here in Monterey Bay have been seen in Southern California or up to the north. So I put this in because I wanted to transition from, people often ask, well, how do you tell a dolphin, what's the difference between a dolphin and a porpoise? Well, in the common, dolphins are members of the Delphinidae family. And remember I said that falcate dorsal fin. I'm going to tell you about porpoises in a minute, but this is one of those fun facts. This is a picture of a dead animal, small cetacean that I found in Baja, California in March. And I could tell very quickly that this was a dolphin and not a porpoise. And we do have harbor porpoises and Dall's porpoises, but the fun fact is this: all members of the Delphinid family have conical shaped teeth. Notice you have the conical shaped teeth. Members of the porpoise or the family Phocoenidae have spatulate shaped teeth. I have no idea why the teeth are shaped differently like this, whether they have a functional role or it's one of these just chance evolutionary oddities. But I think it's kind of fun that you can go walking on a beach and find a lower jaw and say, oh, this was a dolphin, or this was a porpoise. And the other thing is porpoises, members of the family Phocoenidae, have a triangulate dorsal fin. And what I mean by that is a dorsal fin that doesn't curve back, but it's sort of like a triangle. It's hard to see in this picture. This is a Dall's porpoise. We have these in Monterey Bay, and whenever you see them, you see this. There's splashes of water. They very commonly will ride the bow of a boat. They're very energetic. They're big, beefy porpoises. Here's another shot. Again, this is typical. They're just constantly in motion. Again, it's hard to see, but that's really a triangulate dorsal fin. And maybe you can see it a little better here. It's much more triangular than having that recurved back. And so these guys are really common. These are harbor porpoises. So Dall's porpoise, a little bit larger, very energetic, likely to ride the bow of a boat. Harbor porpoise, very secretive. This is a picture I took around the cement ship area. These guys tend to be in northern Monterey Bay, but they scatter, and you'll see them also in San Francisco Bay. They're called harbor porpoises because they typically were found in harbors, but given all of the human activities, that tends not to be the case. They do not have a beak, and they have this other characteristic shape to them. There's two porpoise species on the California coast, harbor porpoise and the Dall's porpoise. I'm not going to spend a lot of time on this figure. I just wanted to say that and I'll talk a little bit more about this. What animals feed on is a big factor in their body size. Remember, I said that blue whales, the largest animal, feeds on really large schools of krill, fin whales on smaller ones. Humpback whales can feed on krill or fish. Minke whales are the smallest. And then we could go through and talk about the different kinds of prey that these animals eat and the different energetic advantages, but I'll leave that for another time. So I did say that I was going to talk about climate and climate change in this talk. I've already given you a little bit of idea about how climate is important in terms of the comings and goings of these animals. I talked about Dall's, common dolphins and Pacific white-sided sort of sharing the habitat, but differentially in terms of the water conditions. One of the things that you've probably all heard about is the El Nino, La Nina, and what is that? And it affects us on land as well, because El Nino is when we tend to get a lot more wet winters. And an El Nino basically is when the trade winds decline and it reduces this upwelling. Well, here we have the trade winds decline. And so the water that would normally be pushed across the equator this way backs up, and the depth of the thermocline goes deeper. And so all that great nutrients goes away. And so the food chain breaks down. So the availability of food is much less here. The reason it gives us winter rains is because this hot, humid air goes out to the Central Pacific. And then you've probably heard the Pineapple Express that brings that cold, that humid, moist air, and a warm, humid, moist air, and drops the rain off the west coast of the United States. La Nina conditions are the exact opposite, where we get really good trade winds blowing. The thermocline comes close to the surface. That warm, moist air moves further across the Western Pacific, and this can also result in more drier conditions off the west coast of the US. This shows the warming in the Pacific associated with an El Nino. This shows the cooling across the Pacific associated with the La Nina. Locally, along the coast of California, this is again a satellite image that shows what happens, the lack of upwelling. In 1998, we had a very severe El Nino event. You can see the lack of upwelling, and amazingly, immediately after that, the following year, we had a La Nina. And so you can see both the seasonality. Here's a full-blown La Nina during the spring. We had really good, strong winds and tremendous upwelling. In previous year, the winds died down. We only had upwelling very close to shore. And again, you can see the seasonality of that, so that the spring upwelling is really important. One of the things we are beginning to learn about climate change is that we think that the El Nino events will become more frequent and more severe with a changing climate. Although we're finding things out, as always, that we think we have part of the puzzle, and then the nature throws something else at us, because we're now getting events that are just these heat waves that we don't completely understand, much more localized events that aren't sort of these global patterns. I'm not going to, due to the time, I'm not going to spend a lot with this figure, other than to say, you can see here's a La Nina. Notice the colors are very different in this La Nina event. And that's because we have these blue, we have these things like Pacific white-sided dolphins and Dall's porpoises, much more common. During the El Nino, we have common dolphins. Remember I said that there's a trade-off between common dolphins coming in up here when it's warmer, and then we have the Pacific white-sided dolphins and the other critters when it's colder. So if we had the time, we could go through this inch by inch, but the idea being that climate drives who is here. Some critters are here throughout the year, like the harbor porpoise is pretty much here. The porpoises tend to be here throughout the year, but they're not as common in some years as others. Okay, in the time that's left, I'll talk about my favorite group, or the group I've spent the most time with, but we'll go through it relatively fast. The pinnipeds, pinna meaning feather-footed. That means they have webbed feet. This is the largest of the sea lion family, Otter. This is a stellar sea lion. Año Nuevo Island off the Central California coast, just north of us from Santa Cruz, is the southernmost colony of a stellar sea lion, and that's where this picture was taken. The most common guy that you guys have probably seen all over the place is the California sea lion, Zoolophus californianus. Males get upwards of 400 kilos, females about 120. Oh, that's a pretty big female. Males are characteristic, have this knob on their head, and this is a sagittal crest. It's what we call a secondary sexual characteristic. It's equivalent to antlers on a deer or on a moose. Again, you can see this male, it's got that kind of knob on its head. And compared to a female, here is a female California sea lion, and here's a male. See that knob on its head? These guys have a lot of different colors. You get chocolate brown, light brown, different color patterns, but they're very acrobatic, very engaging, very curious animals. They'll come in the water, they're very comfortable. On land, they're going to get away from you. They're very skittish on land, but in the water, they're very curious. This is a shot at Año Nuevo. These are mostly, you can look around and you could probably see that most of these guys got that bump on the head. So this is, you can really see it there. These are almost all male California sea lions. The sea lions swim with their foreflippers, and they have ears. That's also why we call them the eared seals. So you see they have ears. They also can reflect their hind flippers forward. So sea lions and fur seals can walk on all fours and swim with their foreflippers, as you can see here, this guy. More shots of mostly females. This is little guy right here is a pup. It's a pup over there. Just a mob of mostly female California sea lions at Año Nuevo Island. Again, you can see the ears. I love I like to call them sea dogs because they really have the temperament of a dog. They're very social animals, and it's just fun to see. If you see them, a group of animals swimming like this that are a seal or a sea lion, this is classic sea lion, very fast swimming. They do this porpoising. If you look at it, I'll show you a picture of a harbor seal in a minute. Harbor seals don't do this. Only sea lions and fur seals do this very rapid porpoising. Sea lions will do all kinds of things. Here's northern elephant seals, and the sea lions are taking advantage of them to rest. So I said we were going to talk a little bit about climate and climate change. And this, and I also said that things are becoming more complicated the more we understand about the oceanography of the ocean. In 2004, 2005, we had a localized warming event where we had, you've probably heard about the blob off the coast here. Well, we had a blob-like event in the 2004, 2005. We put tracking devices on California sea lion males in Monterey Bay, at Monterey Breakwater. And we tracked these guys up and down the coast. These males tagged here were going down to the breeding colonies down in Southern California, that's San Nicolas Island. This is what normal California sea lions do. During that warm event, they were having a much harder time finding food and they went further offshore. So again, it has to do with the food web, and the oceanographic conditions that drive that food web are incredibly important. So this is, we also at the same time, we're looking at female California sea lions. Now the primary breeding colony for California sea lions are the Channel Islands. San Nicolas, Santa Rosa, San Clemente Islands, and Santa Barbara Island, which is too small for you to see, are the primary breeding sites for the California sea lion. That's where most of the population is. We put tags on females on San Nicolas Island, which is right there. Yeah, and this is a normal year. This is the sea surface temperature. So you can see the warm water down here. It's Catalina, San Nicolas Island, San Clemente. So this is colder water up here, warmer water here. 2004, remember we had that warm water event all up and down the coast. You can see the warmer water coming up into around the islands that they're breeding. Females from San Nicolas Island were swimming all the way up to Monterey Bay to get food and then swim all the way back to feed their pup. And they do that. Normally this would be a 3-day trip. They would make 3 to 7-day trips when conditions got harder. 2005, again, that warm water kind of goes further south. And now in that situation, these females were staying closer to the island. Here's the implication of that. If they're spending more time going at sea, that means the pup isn't getting fed. And so if the mom's taking more time at sea to get the same amount of food, overall, it's going to give less food to its pup. 1983, we had one of the strongest El Niños on record. And we lost most of these. The way we follow counts of these animals, because females are at sea, is we count the number of pups. So you can see that pups, significant decline in the number of pups on the beach of all these islands in 1983. We had an El Nino in 1998, and there was again a severe loss of pups. But the following year, the numbers came back up. This year, it was such a severe El Nino that we not only lost pups, but females didn't survive. And so this was a decline both in the year of pupping, but adult females also died. And so this reduction in pup production lasted several years. The other take home from this is that sea lions are doing quite well. California sea lions, we now think, have reached carrying capacity and are at probably the highest levels that we've ever, that historically have seen, which is a good thing. Now, again, I mentioned climate change in this story. And remember, if we go back, I said there were females coming up here to feed, going up to Año Nuevo. And you might ask, well, if conditions are better up here, why don't you just move up here? In fact, that's what's happening. So here's the primary colonies down here in the Channel Islands: Catalina, San Nicolas, Santa Cruz Island, Santa Rosa, San Miguel. Here we are in the 1990s, and we're counting the number of animals that are on Año Nuevo and on the Farallon Islands. So this is the number of California sea lion pups. It was very unusual when I started here working on Año Nuevo to see a California sea lion pup, being a mother giving birth to a pup. Here's that 1998 El Nino event. Animals moved to the north. We had that warm water event. Animals moved to the north. And now we're getting a consistent number. We're now getting on Año Nuevo alone over 1,000, just under 1,000 pups born every year. And on the Farallons, getting over 1,000 pups born every year. So in terms of these long-term trajectories of a changing climate, we can already start to see changes in our distribution of animals. I didn't mention that prior to 1983, we did not have bottlenose dolphins in Monterey Bay. During the 1983 El Nino event, bottlenose dolphins from Southern California swam up here and they never left. And the reason we know that is people were doing photo IDs where they could look at the dorsal fin and look at unique characteristic features of the dorsal fin. 1983, in that warm water event, bottlenose dolphins appeared, people took pictures of them and were able to ID these animals as ones that had been down here in Southern California. So this trend of northward movement of marine mammals that are sort of used to this warmer water is one that is increasingly happening and will continue to change. I'm not going to spend a lot of time today talking about northern elephant seals because I'm going to give a whole lecture on those in the next week or two. I'll just say it's the largest seal, and this is a male northern elephant seal. I'll move on to the harbor seal. These guys are one of the most common pinnipeds throughout the world. They're on the East Coast, the West Coast, they're off Japan, they're off Scotland. They're very unique in that the pup is born looking like a miniature adult. They're all up and down the coast, and they've really figured out how to be cryptic and stay in, be in areas where people are. They lack ears. I mean, they have ears, but they don't have an external pinna. They swim with their hind flippers, and they can't reflect their fore-flippers forward, so they kind of inch along the ground. But they're common. They're all up and down the coast on these little rocklets and islets. Last but not least is one of my favorite animals. I did my doctoral work on sea otters, and sea otters are the smallest marine mammal. This is most likely a picture of a male. The older the animal, predominantly males, they get this blondish coloration. Again, it's probably a characteristic that says it's sort of like a silverback male gorilla. Sea otters are the largest member of the mustelid family. That's the skunks, minks, weasels, badgers, weasels, I said weasel, wolverines. So they're the largest of the mustelids. They're the smallest marine mammal. They're purely coastal animal that feeds predominantly on crabs and mussels and sea urchins and abalone and clams. They've got teeth that are ideally adapted to do that. And the interesting story about the sea otter is that they were, because of their fur, they were heavily hunted. So historically, the sea otters covered all of this range, and they were hunted to the point of extinction. There were just 12 populations, of which 6 survived. One was off California, one off British Columbia, and then throughout about 6 different populations throughout this northern range here. The California population in 1940, there was probably less than 25 to 30 individuals. Right at the Bixby Creek Bridge, they were, quote, rediscovered when they put the highway through, the Big Sur Highway, Pacific Coast Highway there. And they have now almost 3,000 animals in California, and the population is moving both north and south. I won't say too much more about sea otters other than there's again a lot to talk about. And I think I will leave it at that. See if there's any questions, and hope you enjoyed the talk.
Thank you, Dr. Costa. We have a couple of questions here. Let's see. So Todd is asking, let's see. Is there a terrestrial influence to nearshore productivity? For example, did droughts influence the ocean ecosystems?
Great question. So there is the runoff from the land is important depending on the overall conditions. And so one of the things that drives this offshore productivity is obviously nutrients. I mentioned nutrients. Well, we call them macronutrients, or things like nitrates and phosphate. there's also a micronutrient, and it's micro meaning that you don't need very much of it, and that's iron. And so you can have lots of phosphate and lots of nitrate, but unless you have iron in very small amounts offshore, you're not going to get a lot of productivity. And so what we see in wherever there's winter runoff, you get a lot of, there's iron in the sediments. And so when you have a lot of runoff, you'll get a much greater infusion of this iron. You also get iron associated with the continental shelf. And so there is a relationship to the runoff from winter storms that help put nutrients into the water column. So when you have a drought, obviously you're not going to have as much materials going into the ocean to help supply that nutrient load. If you look at large river systems like the Columbia River or the Amazon River, the sediments that go offshore from those plumes and those nutrients, especially the micronutrient iron, fuel a tremendous amount of offshore productivity. So there is a relationship between coastal runoff and primary productivity.
Another attendee asks, why does cold water foster tiny sea life? For someone who hasn't studied this, I'd think warm water would be more conducive to life. The cold upwelling confuses me.
It's not the temperature that's important. The temperature is an indicator of where that water has come from. So the water, it's cold because it's deeper water. So because it's deeper water, that's where the nutrients are, because it's below the photic zone. So it gets concentrated, it's older, deeper water, nutrients get concentrated in that cold water because the thing's settling down through the water column. And then the upwelling brings that deeper water that's full of nutrients up, and that deeper water also is colder water. So you're right that temperature in and of itself would cause things to move faster, but it's not that the temperature is an indicator of where the water is coming from. Where the water is coming from is deeper water below the photic zone. And so that's where it's concentrated with these nutrients, because the plants aren't utilizing it because it's below the photic zone. And so it's cold because it's deeper. It's nutrient rich because it's deeper.
Richard asks, what's the gestation period for gray whales? And is that standard for whales in general?
Yeah, great question. Whales in general gestate about 11 months or so. And if you think about that, it's pretty amazing that something the size of a whale still has a gestation period of less than a year. What's even more amazing is if you think about the fact that it can wean a calf within a year. If you think about how long it takes an elephant keeps its calf for several years, and it only can breed every 8 years or so. And so if you think of something the size of a blue whale producing a calf every other year and being able to do that consistently, that's a pretty amazingly fast reproductive period. Now, if you think about toothed whales, they also have a gestation period that's a little bit less than a year, but they have a much longer development period. So bottlenose dolphins, they're weaned at about 3 to 4 years of age. There are data that suggests that pilot whales and sperm whales don't wean until they're much older. There's data from a pilot whale with milk in its stomach that it was 13 years old. We don't think it needed that, but that says something about the dependency and the sociality of that group. So the mysticete whales are typically not very social. They grow really rapidly. The toothed whales have a high degree of sociality and a much longer dependency period. So the gestation period's about the same. The size of the calf is larger than other mammals, but they're highly precocial offspring. So all marine mammals have highly precocial young, which means they're larger at birth. The other group of terrestrial mammals that have large precocial offspring are ungulates, deers, moose, elk. And that makes sense because when they get born on land, they got to be able to run, because if a lion or something's going to attack them, or a wolf. Same in the ocean. You need highly precocial young, because if you're born and you got to be able to swim and breathe on your own, you got to be ready to got to be at a very advanced state of development. But there's, as you can tell, there's a lot to talk about in terms of reproductive patterns of these animals, which is where I've spent a lot of my time, and it's fascinating. These guys have really done some amazing things in terms of adapting to the ocean. The good news about those fast reproductive rates is humpback whales and the big whales have a tremendous capacity to recover from having been whaled. Humpback whales off Australia our population is growing at about 10 to 12% per year. The California blue whale population is in very good shape, as is the California humpback whale population. And again, one of the kudos to them about having a fast reproductive rate. They've been able to recover from whaling most species. Pacific right whale, maybe 25 individuals left, and that one's scary.
Great. Just one more question, because we're going to be out of time. And actually, there's a number of really good questions. So hopefully, folks will join us again next week, and we can share some more of these questions. I think a lot of these will apply next week also. But what about species with the current time and depth record? Is a good place to leave off.
Yeah, I'll talk about that next time. But the deepest diving, well, the beaked whales, the sperm whale, and the elephant seal are the deepest divers. The elephant seal, the deepest elephant seal is 1,700 meters, 1,750 meters. Beaked whales routinely dive 1,000 meters. So they routinely dive deeper than elephant seals. You know, I can't remember I know the elephant seal records because we're the ones that did that work. I don't know who's the absolute deepest diver, but the beaked whales are the best diver in terms of routinely being able to dive really, really deep and do it where they're working those depths. We don't completely understand, well, we don't understand how they do it. Their physiology is quite amazing. And the sperm whale is a bigger whale, which makes it easier for it to dive. And it's also an extremely deep diver. Certainly 2,000 meters is not outside the range of a beaked whale or a sperm whale.
Great. Well, thank you so much, Dr. Costa, for this presentation. And also, I think that segues well into what we'll be talking about next week, or what you'll be talking about next week, is those technological advances and how you're learning more through these advances in technology. To those of you that are here, the attendees here today, we hope that you're appreciating this as much as we are here at the Coastside Land Trust. What a gift it is to have Dr. Dan Costa here to explain all of this with us. And we have 2 more, so please join us. Get back onto our website. For all of you, you'll actually be receiving an email in the next few days, with information to sign up for the next one. And also, these will be recorded, so you can look at these, share these. We'll have them up on the website, but you'll have an email copy of this as well. And for those of you who are able, please consider donating to the Coastside Land Trust and all this important work that we are doing to preserve land, and also to continue to meet with folks that are helping us all to learn a little bit more about your local ecosystems and here are the marine mammals right off our coast side. So thank you, Dr. Costa. We will see you again next week on Saturday on Halloween, the 31st at 10 a.m.
All right.
All right. Thank you all. Thank you.